These are fascinating times. Chaos, fractals, dynamics, all of these are terms that are very much in the news these days. It's a fascinating area of mathematics. So fascinating is because, as you'll see today, the computer graphics images that come out of the field of dynamics are beautiful. There's something in these computer graphics that strikes the human eye as quite alluring. Another reason for the fascination with this field is the fact that it's so exciting. Much of this mathematics is very accessible, the kinds of things that students in high school know quite a bit about. Let me begin by showing you a videotape of some of the computer graphics images that come out of this research. Basically, a dynamical system is any process that moves or changes in time. On the other hand, the weather or the stock market. If I knew where the stock market would be tomorrow, I wouldn't be here today. I'd probably be on some beach catching the rays. Well, on the other hand, to simplify the situation, let's begin by talking about a mathematical dynamical system, very simple abstraction of the kinds of dynamical systems that arise in nature. Well, and so forth, the square root of the square root of the square root. It's a dynamical system. So to illustrate that, I brought along my own home computer, rather homemade computer. I call it an iterator. X squared, square root of x, 1 over x, etc., which you can iterate. Well, let's start by inputting the favorite number into the calculator, 256, that's 16. Get 256. Anyone know? Now, once more, 0.032. See the pattern yet? Probably not. Okay, well, now let me interject some mathematics into all of this. A couple more examples. Well, by going to the graph and over, 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 etc. Now, now let me move to some of the most interesting dynamical systems. So, notice that this Julia set basically looks like a fist with infinitely many fingers attached. The red area looks like a fist with lots of fingers dangling from it. Now look at any one of the fingers. In the complex plane, plus pi over 2 and minus pi over 2 are right here in the belly buttons of the infinite snowman. Your homework problem is to explain what you're seeing.